So section 1.8 gives you a lot of problems on inequalities, absolute value inequalities, rational inequalities. I'm going to hit some highlights here. The first thing you have to do is you have to get 0 on one side. That we've already done. So let's keep going then. We also need to figure out where this is actually equal to 0. That's where it can change signs, and that's where we're going to have to test points. So towards that end, I'm going to factor out the x from there. That's going to be behind x squared minus 36. Still want to know where this is greater than 0. Then this continues to factor x. And I don't know, maybe somebody can help me out. How would x squared minus 36 factor?
X minus 6.
Awesome. X minus 6, x plus 6. And hopefully from here you can kind of read off where this would actually equal 0. That is, if you had x times x minus 6 times x plus 6 equals 0, that can only be true when one of these factors is 0. So that means either, well, x equals 0, or x equals 6, or x equals negative 6. So those are our three possibilities. That's where the function can change signs. So what we'll do is we'll put these points on a number line, negative 6, 0, and 6. Now personally, I suggest this part next. You write down the intervals that these points break up your real line into. So that'd be negative infinity to negative 6, negative 6 to 0, 0 to 6, and 6 to infinity. And the reason for that is because when we start throwing in some test points, people get confused with their test points and the endpoints of these intervals, and they make mistakes. One or more of these is probably going to be your answer, so it's nice just to have them written down right now. Now I need some test points. I need to find out where this expression is positive or negative. So I need some test points in the interval negative infinity to negative 6. Suggestions? Negative 8. All right, good. Let's keep going around. Somebody else for another one. Negative 5. Awesome. Maggie, how about another one? 2. And Grace, one last one. 8. Excellent. So those would be our test points. Now I've already got that expression into my calculator here. You don't have to put it in factored. You could. If it's easier, then do it. Double check to see that your setup is correct. We've got independent set to ask, dependent set to auto. Great. Go over to the table. I'm just going to clear out all the old stuff and type in our new points. Negative 8, negative 5, that's negative 5, 2, and 8. Now I don't really care. Let's see, I must have messed up someplace here. Let me try it again. So negative 8, negative 5. I think I must have multiplied them somehow. And then 2, and then 8. Okay, so let's see here. Now, I don't really care that when I plug in negative 8, I get negative 224, or when I plug in negative 5, I get 55. What's the important information I need to get from this step right here? Where it's positive or negative. So, as is typical, not always, not guaranteed, as is typical, you have a alternating pattern. So what did it start out with? Negative, negative, positive, negative, positive. Let me just double check that real quick. Yeah, negative, positive, negative, positive, negative, positive, negative, positive. Which interval or intervals make this true? That is, which intervals have values of x that make this greater than 0? That would be your positive intervals. So those two. So it would look like this for your answer. Negative 6 to 0, union 6 to infinity. Now in WebAssign, they might have you put this in with a comma between these two. I'm not sure. But this is the correct answer on that one.
So it's not always negative, positive, negative, positive, positive, negative, positive. Sometimes it can be like
Yeah, sometimes it might be negative, positive, positive. That's going to happen if you have something like if I had x times x minus 6 squared. In that case, you'd have zeros at, say, 0 and 6. And let's see, I think it's going to be negative, positive, positive if you did your test case there. And that's because this is a squared term. And when you square something, it's always going to be positive. So it doesn't change signs like you would have up here. So that's what's going on with that case. Then, and you don't get the typical alternating pattern that you do in most of these types of problems. So, good question. Anything else on 1.8 here, or on this one right here? Certainly we've got a couple more to do from 1.8. One of them is regarding rational inequalities. So 1 over x plus 3 plus 1 over x plus 4. And this time, let's make that less than or equal to 0. Once again, fortunately, we've got 0 on one side to start with. But here we do have a little bit of extra work to do, in as much as you have to write the left-hand side of this rational inequality using one term. And what that means is that we're going to have to get common denominators and bring things together. Now our LCD in this case, and you have to regard these as whole terms. It's not going to be x plus 12. You can't split it up like that. It's just going to be x plus 3 times x plus 4. By the way, I did throw out a little extra quick video vignette on LCDs. If you haven't taken a look at it, then it is worth 7 minutes of your time. Let's compare this to our LCD. I'm missing the x plus 4 term. So I'll multiply by x plus 4 over x plus 4. Over here, I'm missing the x plus 3 term. Great. Let's see what that gives me. Now, I'm going to be kind of a little bit lazy, but it's lazy with a purpose on these next two. Here in the numerator, I've got x plus 4. Over here, I've got x plus 3. Part of the reason I like writing LCD is because a lot of people are tempted to say, oh, well, I can cancel the x plus 3. But that would take you back to where you started. So I find that people don't cancel that term if they're just writing LCD. In any case, these are common. They have a common denominator, so I can bring them together over the LCD. And that would be 2x plus 7. All right, let's take stock of this now. I need to figure out where the numerator equals 0 and where the denominator equals 0. So numerator equals 0. That's where 2x plus 7 equals 0. So x equals negative 7 halves. Can you read off where the denominator equals 0?
Negative 3 and negative 4.
Awesome. Negative 3 and negative 4. Thank you, Carl Espy. Let's put these numbers on the number line. So, kind of in increasing order. Now, this is going to be a little tight here. You've got negative 4 and then negative 7 halves. And I'll remind you that that's negative 3.5 and then negative 3. So they're kind of crammed tightly in there together. Well, okay. We're still going to need to test some points. It's not a bad idea to write down the intervals like we did before. So negative infinity to negative 4 to negative 7 halves, negative 7 halves to negative 3, and negative 3 to infinity. Your answer is going to come from these intervals. You still need to test points to figure out which one's going to work. This one gets a little tight in here, right? Because you've got negative 4, negative 3.5, and then negative 3. So as far as our test points are concerned, I mean, we're not too bad here. But these middle two, they're going to be tight. On the ends, I'd choose a 0 and maybe -5. But can somebody tell me a number between -4 and -3.5?
3.75.
-3.75, sure. You're going to have to use decimals. And then one more right here, say -3.25. Or just -3.3 or whatever. Whatever fits in there, whatever works for you. Let's put those expressions into our calculator. So let me go up here to the y equals key. I'm going to clear this stuff out. Now, as you put this into your calculator, in the numerator, you're going to need to use parentheses. Parenthesis 2x plus 7. And then close parenthesis. Divided by. And then the right parenthesis, excuse me, a left parenthesis, and then another left parenthesis. You need 2 of them. And that's kind of a pain there, but you need 2 of them. Otherwise, you're just going to be dividing by the first one and not the second one. Let's see, it would be x plus 3, and then x plus 4. You want both of those terms in the denominator. That's why you need that extra set of parentheses. So that's the way it should look.
You don't have to do the parentheses if you're doing like
Well, I'll show you the fraction. Now, if you're like, oh, I don't really like those parentheses, there is a workaround if you have a nice up-to-date calculator. If your calculator has the latest operating system, 2.55 MP or better, then you can do this. You hit the alpha key, and then the y equals key, and then it gives you an option to do a fraction kind of the way I write them, less the way that we input them into our calculators, typically. And now I've just got a numerator denominator, and I don't need the parentheses on either one. So 2x plus 7, and then now I do need parentheses here, x plus 3, and then parentheses x plus 4. The difference is I don't need that extra set of parentheses like I had with the first example. Now let's watch what happens when we do our table setup. And it's just a good warning as to, well, all right, there is maybe a little bit of a downside to the way we put it in Y2, but not much. So we'll go to our table, second table. Let me delete all these things. Yeah, it gives it to you in the form of fractions, which is okay if all you're looking for is the sign, but sometimes you want an actual decimal value. And that, in that case, it can be kind of a pain, -3.75, then -3.25. And finally, let's just do a very simple one. We'll type in a 0. Now, either one of these columns gives you the information you need. You need positive, negative, that kind of stuff. So let me write this down. It goes negative, positive, moving left to right. Negative, positive. Which intervals do we want? Do we want the negative intervals or do we want the positive intervals? You want the negative intervals. So we want this one and this one. But because there's a less than or equal to, you got to think about the endpoints. So let's test the endpoints here. Can we use the endpoints? Well, if I plug in -4, it gives me an error. Oops. Did I do something wrong? Wait, what did I do wrong? Did you guys get error too?
I got a 0.
Yeah. Uh-oh, there's a mistake there. No, you should be getting an error. Now, that's actually not a surprise. The reason you're getting an error is because if you put in -4, you get 0 in the denominator. And that means you're trying to divide something by 0. So we can't use -4. What other number can't I use? -3. I can't use either of those. But how about the -7/2? This endpoint, can I use that one? Well, let's test it. If you type in -7 divided by 2 or -3.5, either one, oh, I get a 0. Well, let me ask you this. Is 0 less than or equal to 0? Is that true? So I can use that endpoint, but I can't use the other ones. So my overall answer is going to look like this. -infinity to -4 union, then bracket -7/2 to infinity. Awesome. Now there's one last thing that I wanted to hit here with you guys, and that is absolute value inequalities. Anything on this before I move over to that Desmos link I put out on D2L? Is it negative? Oh, yeah, my bad. Thank you. Yeah, it should be -3. -3. Awesome. Thank you, sir. All right. Let's take a look at absolute value inequalities. And I gave you this link here. Oh, you like absolute value inequalities? they're your favorite. Yes. Well, I guess what I want to impress upon you here is kind of like the answer to a couple questions. So we've got a couple things in the homework that you're going to face that look like this. They're like, okay, well, what's the inequality that goes with that? And to understand this, realize that it comes from an absolute value inequality of some sort. Now, the way I've got this set up, we can adjust a couple things. Right now, I've got x equal to 0 and b equal to 4. So effectively, what I'm graphing here is the absolute value of x is less than 4. Let me write that down and take a look at it with you. And also what I have graphed is the solution to that. And the solution to that is this. Everything between -4 and 4. That's the solution to my inequality. Now, let's play around with this a little bit. In fact, you play around with this. Why don't you move b, make it bigger and smaller? And you see what happens, right? The solution gets wider or narrower, depending on the value of b. So, okay. And in fact, let me put it down here. If I adjust it this way, can anyone tell me what absolute value inequality this one would have to be? What would something like that have to be without seeing what I wrote? This would have to be absolute value of x is less than 3. Sure. All right. But what if I did an absolute value greater than case? Let's shut this off for the second and turn this one on down here. This is the absolute value greater than case. Notice it has two intervals that face away from each other, right? Not one interval in the middle like this. I'll turn that back on for a second. That's your absolute value less than case. Here's your absolute value greater than case. Two intervals that face away from each other. So, wow, okay. But again, you can play around with b. You can make this bigger or smaller. In fact, if I made it b equals 0, I would get like everything, right? Wow. So with that, I can actually answer some of the homework questions that you're going to face. Let's take a look at this first one here, what I called example O. First question to you, is this an absolute value less than case or absolute value greater than case? Greater than case. And what's it greater than? 2. Yeah, this is just the absolute value of x is greater than 2. So, nice. How about this one down here? Is that absolute value greater than case or less than case?
Less than 3.
Less than. Yeah, less than. And actually, let's be very careful about this. This would be less than or equal to 3 because you're actually including the endpoints. All right? Now, there's one last little trick here that we got to look at as far as these are concerned, and that is, What if A was something different than 0? So let me shut this off and turn this one back on, the absolute value less than case. Let me start shifting A. And notice what it does. The length of this interval is still the same. It's just shifting where it's at. So let me make this a nice even number. Let's go for 2. Maybe we'll do 3. We'll do 3. There we go. So I'll make that 3. And, okay. I want to make that, as you move this around, the length of the interval is still the same. And you can actually reverse engineer these. So in this case, what's the middle of this interval? It's -3. So that means you'd have an absolute value term like this. It'd be the absolute value of x plus 3, which you could think of as the absolute value of x minus -3. And that has to be less than the width of your interval, or half the width of your interval. Let's see. So that whole thing is worth 6. From the middle to the end, that's a distance of 3. So this would be your absolute value inequality in a case like that. Absolute value of x plus 3 is less than 3. So again, you can kind of reverse engineer these things that way. Let's take a look at an example, again, from the homework. So the middle of this, let's see. You've got 5 to -3. So the middle should be 1, right? That's what's in the middle. First question to you, is this an absolute value less than case or an absolute value greater than case? Less than. So I want my center to be at 1. So I've got x minus 1. It's an absolute value less than. Actually, let's do a less than or equal to. And now we have to figure out the distance from the center to one of these edges. How far is it from the center to one of the edges? Either one. Distance of 4. So that's it. The absolute value of x minus 1 is less than or equal to 4. That's your graph. Or that's what would result in that kind of equation. All right. I've chatted enough. Let me get you working on some homework. Questions on this one before we roll? All right. Good luck.